So then I start briefly with the topic electronic device description. Mr. Gedenk has already shown about the devices, can OpenFD devices and so on. But every device should have something like this. And this would be my presentation to this topic. Briefly about myself, I'm an electrical engineer working for CiA Automation for more than 15 years now. I'm supervising multiple working groups, helping out to write can Open, can OpenFD, can Excel, can FD-based specifications. Beside that, I'm also testing engineer at CiA Automation, testing can Open and can OpenFD devices for their conformance. That is what I'll be also mentioning in this presentation as well, the testing. And beyond that, I'm also as an expert in standardization working group for the drives. So now let me start a brief motivation why we had done so for already 20 years and now the same. Every device shall have a description of it, preferably electronic, especially in the times where we're talking about and working with distributed systems, field buses, and embedded networks. More of that, we need a standardized approach to this description. So the ISO 15745 for industrial automation system has designed the rules and regulations how such a network and the description of devices, profiles, and other key parts of the system should be represented in itself. So that is where we start with. We use this, of course, in a first edition of our XML-based device description, known as specification 311 from CanOpen, from classic CanOpen. Now this technology increases, its potential is increased. XML technology, TCP/IP, networks, global networking, clouds require universal data exchange mechanism, universal languages for markup of the descriptions, that it could be available throughout various equipment pieces across the globe. So for that reason, there will be industrial embedded network communicating over the multiple backbones in the cloud. There will be exchange there are existing already embedded gateways, and in there such a device description from each single network and each single device in the network should have also standardized interface. The other key motivation points are also device accessibility should be available in a way that addressing of each single device, its parameters, functionality should be based as physical, addressing directly the parameters as the logical. It should be a kind of mechanism like switching the lamp in a production hall in a factory, switching lamp on even switching some production line elements like that. So the devices should be testable, and the device description should be also standardized to fit most tools available for XML, and should be able to simply parse these tools, simply parse these files and get them tested in a universal environment. In this topic, we speak about CanOpenFD, so 301 specification. This is base specification and the testing of XML-based device description and checker, which are already available on the market, should be achieved by this. Least but not last, let's say in this part would be or is actually cybersecurity considerations, which are in a very early development stage. Also in game automation, we'll learn one or two things about this in presentation of Mr. Olaf Pfeiffer. We have Cyber Resilience Act, where we should employ the means to protect the software, especially the device description in whatever form it is presented should be also protected in this way. Another thing is which security level should it be just for the data itself, and it should be also considerations made for industrial automation, for cyber security in automation systems. That is more or less described in standard IC 62443. Key features of device description is actually approved by one of the working group that my colleague and our director, Mr. Zitzmann, already presented. Canopen IG, Canopen FD decided that we need for Canopen FD devices one single description format. It should be XML based, ISO 15745 based as its predecessor. As I said, Canopen, classic Canopen has already fully fledged XML-based device description, was modular, multifaceted one, but too complex for devices, systems designed many years ago. Nowadays, the power of power consumption, production, and capabilities of even microcontrollers and industrial PCs are grown ever since. And if we consider also cloud-based applications, that XML-based device description is the way to go with it. We defined several formats in there for similar as it was done with classic Canopen and Canopen, classic Canopen as EDS. Its pendant is in here, is actually XDD, this XML-based generic device description. Then there was also configuration file where you could put the data for pre-configured system, and pre-configured device inside is called in XML-based XDC. And finally, we have also specific profile description, which has more or less a reference to a whole network design of the system. Another topic is, which we have also in the development, is configuration files in binary format and concise device configuration file known as concise DCF, also from the times of classic Canopen. That things we want to keep, and we want to also to reuse or redesign a binary configuration file format. It was not designed into classic Canopen. It was partially manufacturer specific. Now we want to make it a standardized format to be used. Because of certain cybersecurity concepts and considerations, such a configuration file will be less prone to cybersecurity effects or attacks from outside. Since we talk about standardized approach to design of open system integration framework, I would go into a few slides to show how the things are working in there. So basically, this is a picture of a diagram of a concept from the standard. We have on one side a generic rules and regulations. On the other hand, They have then specific parts which address to very specific systems and such kind of field bus. As you can see, the part 2 addresses CAN-based control systems. So that is why I've shown this in a diagram. This is important in that. And there is small amendment which provides the templates for XML-based device, network, and communication system description, which are all reused in this. And as come inside, and from this one we generate actually the whole device and network profile XML based for CAN-OpenFD. In the middle, you see this is typical structuring of the ISO 15745 specific standard. Into this concept, I've applied this to CAN-Open. There are resource profiles, process profiles, also material, human profiles, and so on, which are not actually important in this. From our point of view of embedded CAN-Open network, or rather CAN-OpenFD network, the resource profiles are important. Other things mentioned here, they are actually manufacturer specifically defined, can be defined also in XML format. From this point of view, we have already done most of the part. As you can see in the resource profiles, the communication profile is based already on existing specification of CAN-OpenFD, and device profile is based on our existing CiA profiles, device profiles, application profiles, and so on. So basically, on the left-hand side, in application, there are real-life applications, networks, and they're coming inside, and exchange of data goes in both ways in this case. So another thing is also modularity of this standardized approach. We can have multiple communication profiles to one single device, assuming we have CAN-OpenFD device, but it is not only supporting CAN-FD, but it also Ethernet can be also Ethernet based, like EtherCAT or Ethernet PowerLink. That is the basic idea. We have device description, and we can have multiple communication profiles in one device description, allowing to manage this device in various networks and apply into various systems. Just an example how this device and network description look like. It's much bigger than this. I've just wanted to point out that this description is a screenshot of a real-life device description file we've generated already, although it says unknown, but was just exemplary one. On the left side is this device snapshot from, or snippet of, let's say, of the device description. On the right side is snippet of the whole network description. In the whole network description, this is where the profile technology and communication, various communication profiles can be residing. So again, reminding on a previous slide, there could be multiple communication profile and one device profile to one device profile using this standardized approach that we also keep in mind here. Just a few slides about XML scheme, because the standardized approach suggests all the XML-based device description will be generated, as usually is done, based on XML scheme. For that XML scheme, we took one existing and reduced it to the minimal necessary functions. There's all mandatory functions in there. This XML scheme is the base for generating every XML-based device description, device configuration, and profile description files. One scheme allows to generate those one. It is standardized, or let's say specifies in this case, in CiA 1311-1 specification of ours. It is available, you can use it, and there are also tools allow you to generate from your scheme the file based on this specification. We came also to with the approach to make very simple device description fitting simple devices and allowing to gradually mount the more complex description in there. But the basic idea was to make it fit for a plain, simple CanOpenFT device description. So it features, of course, device description features all the options, all the functionality, most of the functionality needed from basic CanOpenFT specification. So the services are actually not described because it's the markup language, XML markup language, and device description describes device support of certain protocols and services, and specifies its object dictionary. These all things are now done again, but in very simple way in comparison with CiA 311 into specification 1311. As I've mentioned also previously, we have also system-wide and network-wide possibilities. My colleague has mentioned also logical addressing and remote access. For the cloud-based application. For that reason, we have also embedded in device description network ID, CanOpenFT network ID, and also a new thing, so-called reference designator. And finally, the XML scheme, one scheme available for wide range of file formats, simple device, profile, definition, and configuration file are supported. To make it also modular, to design such, to generate or parse XML device description, we separated, as it was already done in a classic CanOpen with 311 specification, XML for classic CanOpen. We split single parts of XML scheme into several files, which are hierarchically organized to allow you to generate from that, based on your features, generate ISO 15745 structure, which can be used in every such network in industrial automation. You can see CanOpenFT base file, which describes just basic features, then common elements used independently from technology inside, then ISO 15745 specific structure of profile. Then we have profile body device profile description and profile body network. What is the difference? In device, I specify device parameters, its specific functions, while in network, I specify network ID, network-related features, network identifiers as well, and how the network is built up. There is an option or options in there to add some additional features, like describing a whole topology of the network with where the device is residing, but that's is already a topic for system integrators in S. In the next few slides, I would like to briefly show several examples. How does it look like? First of all, I would like to point out a piece of scheme, how it is generated. And important thing is in here that we are currently working on putting the website with a definition scheme for this XML format for CanopenFT. We had such a website. You can find this the target namespace. We have this such a website for Kanopen, for classic Kanopen, and now we mount to do the same for CanopenFT. So if you use it, you can reference in your parser, XML parser, also this web address with reference to all rules and regulations of this internal device description. And here's just a simple example how the device identity will look like and so on in a profile body device, which is actually device profile, piece of device profile description. That is all about this one. Now is the application beyond integration, which is also interesting topic, but I think it would be much more interesting as a separate technology in the separate technology days with integration concepts. Device description is typically used for configuration of the device, integration it into the network, and occasionally also performing diagnostic feature using the device description. Another topic of this is actually testing of the device, if not the network. We reuse our device testing, CanopenFT device testing. This is where the device description is being tested as well. As of right now, as we have no test tool for CanopenFT, but we have a test procedure, and we perform a test procedure according to this block diagram, as you see of this test bench. The only thing that we don't have is the upper test. This is actually the application test. What we can do, we test statically Canopen object dictionary and protocol efficiency of the device as a black box, actually. We don't know what it is inside. We check just its response. And in this case, we have inside already XDD checker and some tools where we can access CanopenFT data from any device. As I said, there are already XML-based checker for XDD, for CanopenFT XDD available on the market. We have no test tool, as I said, but we define a test procedure. You can find this also on our website. You can download it. And if you send your device to us for testing, will be the way we do so. And the device description, we use the tools to test the device description in there. Beyond this part, there is also a test plan defined. It's also completely specified, it's available. You can look into this. We have, as a part of it, we have already a device description testing. This is a part of the test plan. You can look into this so you know what of the device description we actually test in XML format. And finally, related standard specification, which might be of interest for you if you start designing your Canopen device, where you find device description, how should it look like, where do I find test plan, how do I design my specification, how do I design my device, what is the communication profile, and which profile do I take. These things are listed here and for reference, also to structure of open system application integration network, where this XML description also comes out for GNOPEN-FD. Finally, the topic, what is available, we use only XML-based device description, no textual format description, as we agreed. Then binary configuration file format is in development. Tools for XDD check are available. Tools for KNFD and thus also for GNOPEN-FD, for reading GNOPEN-FD messages, are also available on the market. It is interesting to say that EMOTAS, EMSA, and microcontrol offer the wide range of the tools for exact these reasons. So you'll be very good kept informed by these companies. Finally, that we have a test plan and a test procedure if you need and require to test your device automation. You're welcome to do this at our company, send it. We'll test this for the moment with the test procedure. Still in development, cybersecurity considerations, cybersecurity on this one. That is clear that also device description should be more or less protected, especially in case, even if it is transferred or across large distances across networks in a host controller, which controls multiple embedded networks. That would be but a part, hopefully a part of the presentation of Mr. Pfeiffer.